Hi everyone. Today let's talk about sessions 5.2, the normal distribution. Definition. A random variable z has the standard normal distribution, also called the Gaussian distribution, if it has the PDF. So this is the PDF. So last time we talked about for discrete random variable, we have PMF, probability mass function. And for continuous random variable, we're going to have the PDF, probability density function. So that in the remaining sessions of these chapters, we will go over different kinds of continuous distribution. The standard normal distribution is the most common distribution in the world, okay? And the picture of it is like this. Okay, we always draw like this picture, okay? So this is a standard normal distribution. The mean is the center, that's 0, okay? And this is the PDF. However, we don't use the PDF to calculate. Okay, we use the CDF to calculate for the normal distribution. And 0 is mean, and the variance is 1. Okay, so this is the standard one. All right. So here are some remarks. First, the integral from minus infinity to infinity f of x dx equals to 1, and f of x is greater than 0 for all numbers for all real numbers. Okay, for all x in R. And furthermore, f is an even function. So you can see this picture. We have mirror image. So the graph is symmetric about the y-axis. Okay. So because of these two properties, we know f is a PDF, okay? And the probability of x less than or equal to small x is going to be the integral from minus infinity to x of f of x. Sorry, we should use another parameter, okay, y, dy, okay. So this is the CDF, okay. So because the normal distribution is so special, so we use this notation phi to denote the CDF, okay. So this is the CDF. And for the standard normal distribution, we use the z to denote. So usually when we have a random variable, we use x to denote. But because this standard normal distribution is so important, so we use z, special letter z, to denote the random variable, and we use phi of x to denote the CDF of the standard normal distribution. Okay. And the mean of the standard normal distribution is 0, and the variance is 1. Okay, it's also equals to the second moment of this standard normal distribution. Okay, so notation. C sub alpha is the value x, where p of x greater or equal to small x equals to alpha. So if we want to draw the picture, so we draw the picture. This is a picture. So what is the alpha? So z sub alpha is a x value such that the probability of x greater or equal to this value equals to alpha. Okay, so this is a picture, and so that's why we know what is the CDF. CDF denotes the probability that's on the left hand side of this number. Okay, so this area is actually the CDF, and because we know the whole area is 1, and then because this is alpha, so on the left is 1 minus alpha. All right. So z sub alpha is the x value, where the phi of x, the CDF at this value, is 1 minus alpha. Okay. So in all the previous distribution, when the problem asks us questions, they'll like give us the x values and then we find the probability. But in this session, the problem can ask us two directions. One direction is given the x values and asks us to find the probability. So this way is similar to what we have done. The other direction is they can give us a probability and then ask us to find the x values. Okay? So let's look at example 1. Example 1, find z greater than 0 so that probability of z lies in the interval minus z to z. The probability equals 2/3 if z has the standard normal distribution. Okay, so let's draw a picture. Alright, so let's draw a picture. This is like a mountain. Okay, and the middle guy is always 0. Okay, so what do we want? We want a number z that is positive so that from minus z to z, so minus z because it's symmetric, so we have minus z here, so that the probability z lies in this range. So this probability, this area equals to 2/3. Okay, so if this area is 2/3, then what is this little area? Okay, because the total is 1, right? And this little area is the same as this little area, and they add up together is, so those two areas, they're the same. They add up together, and we will get 1/3. Okay, because the total area is 1, and then the middle guy is 2/3. So those two small pieces add up to 1/3. Let me use a different color to denote that. So it's this piece and this piece. They add up to 1/3. Then how about each of them? So each of them, okay, each has 1/6 because the area are the same, right? So they add up together equals to 1/3. Then each of them has 1/6 as the area. Okay. So now what is z? Okay, so we have the z here, and this guy is 1/6. Then what is this guy? Well, this guy is 1 minus 1/6, which is 5/6. So z, we have the z such that phi of z, the CDF of z, is the area on the left of that z number. Okay, that is 5/6. And what is 5/6? Well, that's approximately equals to 0.8333. Okay. And to calculate the standard normal distribution, we use the CDF. Okay, we use the CDF, and the CDF is in table 3. Okay, so CDF in table 3. Okay. Okay, what are those tables? Remember, table 1 was the CDF for binomial distribution. Table 2 are the CDF values for Poisson distribution. And table 3 are the CDF values for normal distribution, standard normal distribution. Okay, so let's look at our table. Here is the standard normal distribution function, okay, the CDF for that. And we are looking for the probability. So here are the probability, and here are the x values, okay? So what does this number means? This means the CDF is of negative 3.03. Okay, so this guy means phi of negative 3.03 equals 0.0012. Okay, so this is what it means. Okay. right, let me erase it. Okay, so now we're looking for the probability equals to close to 0.8333. So let's go down. Do we have, so you can see all the probability are increasing, okay, because the actually the CDF or continuous random variable is always increasing, okay. So the value is not here, so let's go to the next page. Okay, so next page we have here. Can you see some number close to 0.8333? So I would say somewhere between here, right? So 8333 probably is closer to this guy, right? And what is the corresponding x values or z values? That corresponds to 0.97. So we have phi of 0.97 is 0.8340. Okay, so let's come back. So we know that we know phi of 0.97 equals to what is that number? 8340. Okay, so that's why the z value is close to 0.97. Okay, so this is from table 3. Okay, so we get our z values is close to 0.97. So this is given the probability and we find the z values. Okay, all right. Next, if z has the standard normal distribution, okay, suppose mu and sigma are any numbers, then x equals to sigma z plus mu is a random variable, okay? And what's the mean of that? Well, you remember the mean of sigma z plus mu, okay, is sigma of e of z plus mu. And then because e of z, so the mean of the standard normal distribution is 0. Don't use the mean here. Okay, so e of z is 0. So we get mu. What is the variance of this new random variable? Okay, so that is, remember, variance of sigma z plus mu is sigma square variance of z, but variance of z is 1. Okay, so that's why we have sigma square times 1 is sigma square. So now we have defined a new random variable where the mean of this new random variable is mu, and the variance of this new random variable is sigma square. Okay, so now it's the time to define a normal distribution. So a random variable x has the normal distribution. We also call x is a normal random variable with mean mu and variance sigma square if it has PDF this. And you can see the difference. What's the difference? Well, x equals to sigma z plus mu. Then what is z? Well, you subtract mu on both sides. Z is then x minus mu over sigma. So this is a relation between a standard normal distribution and a not standard one. Okay, so let me use here. Okay, so z is the standard normal distribution. Okay, now x is any, in general, any normal distribution. So x is just normal distribution. Okay, and we use notation normal distribution with mean mu and variance sigma square, where the standard one is the mean is 0 and the variance is 1. Okay, so this is the relation between the standard normal distribution and a general normal distribution. Okay, so that's why we have our standard one. This is the formula for the standard one. Now you replace the x by, because that was like the z, you replace it by x minus mu over sigma. So you get this new function. So this is the function for, oh, sorry, this is small x. So this is a function, this is a PDF for the normal distribution. Okay. So, given any kind of normal distribution, how do we calculate the probability? Okay, so the trick is because we know the CDF values for the standard normal distribution. So, given a general and normal distribution, we're gonna transform to the standard normal distribution. Okay, that's n 0, 1, and we use z to denote. And here we use x to denote. Oh, my notation should be this. Okay, and then we can use the CDF values in table 3 to calculate. Okay, so this is how it works. Alright, so let's see how we solve this example. Probability of x less than equal to minus 1.7. How do we change to the standard normal distribution? Well, keep in mind, z is x minus mu over sigma. Okay, so here, what is mu? Well, mu is -3, and sigma square is 4. Then, what is sigma? Sigma is 2. Okay, so what do we do to the z, to the x? We want to subtract the mu and then over sigma, right? So, we do the same operation to the negative 1.7, so we subtract mu over sigma. And what is our mu? Our mu is -3, so it's like we use x plus 3 over sigma. Sigma is 2. And we do the same thing to the negative 1.7. We add 3 and then divide it by 2. Now this guy is the z. Okay, so we get pz less than equal to 3 minus 1.7 is 1.3. 1.3 divided by 2 is 0.65. Okay, so now z is the standard normal distribution. And great, we want to use the CDF to calculate. And here, less than equal, that's awesome. That's exactly the CDF. So we have phi of 0.65. Okay, so what is phi of 0.65? Okay, phi of 0.65. Let's look at our table. 0.65. So the z values is 0.65. So this is our number, 0.7422. Okay, so let's come back. So here we get from table 3, this is 0.7422. So this is the probability. Okay, so I actually want to ask you more questions. Okay, so let me create a part B here. Okay, let me create a part B. So this is like part A. Part B. So part A direction is I give you the x values and ask you to find the probability. Part B, I want to give you the probability and ask you to find the x values. So let's find the 95 percentile. Okay, what does that mean? 95 percentile. i.e., we want to find the x such that the probability x less than equal to small x equals to 0.95. Well, the picture is here, this is the x value, so this guy is 0.95. Okay, so x is like the 95 percentile. Okay, so how do we do that? So this is what we have, but we want to transform into the standard normal distribution. How do we do it? We subtract mu over sigma. Okay, so that's why 0.95 equals px less than equal to small x. And subtract mu. Mu is -3 over sigma. Sigma is 2. Okay, now this guy is z. So this is probability of z less than equal to small x plus 3 over 2. Well, that's exactly the CDF at x plus 3 over 2, right? Okay, so we know the CDF values equals to 0.95, and we want to find the x values. So let's look at our table. Our table, the CDF values is 0.95. So we want to find the probability that which one is closest to 0.95. So 0.95 is somewhere between them, right? Somewhere between them, because you can see 0.95 is exactly in the middle of them. So that corresponds to 1.64 and 1.65. So in the middle, then it corresponds to 1.645. Okay? In this case, because it's right at the middle, so we know it's at the middle of 1.64 and 1.65. In other cases, you just need to find a probability that number that's closest to our values, and then you can use the corresponding x. Okay, so the x values is 1.645. so here we see that. Okay, so the values x plus 3 over 2, that is 1.645. And then we can solve for x. Okay, so this is from table 3. Then we solve for x. We multiply by 2 on both sides. When we multiply by 2, we get what? So 1.645 times 2. You can also plug this in your calculator. I get 3.29. Okay, then x is 3.29 minus 3, which is 0.29. See, we have found the x. So this is the 95 percentile. All right. So we have done 2 directions of this problem, right? Given the probability, find the x values, or given the x values to find the probability. All right. So yeah, remark, we use z to denote the standard normal distribution, and phi of x is the CDF of z. So usually we just put f of x to denote the CDF. But the standard normal distribution is so important. We use phi of x to denote. Okay? All right. So let's look at example 3. Let x be the amount of instant coffee filled in a 4-ounce jar. It is a normal random variable with sigma equals to 0.04. If only 2% of the jars are to contain less than 4 ounces, find the mean mu. Okay? Alright, so here we know the probability and we want to find the mean mu. Okay, so let's see how we set it up. Okay, so X is the amount of instant coffee filled in a 4-ounce jar, and only 2% of the jars to contain less than 4 ounces. So that means the probability X less than 4 ounces. Only 2%, 0.02. So this is what this sentence means, right? Okay, let's see. What is that? Well, that is... Okay, remember when we're given the normal distribution, we want to transform into a standard normal distribution. And how? We subtract mean over sigma. Okay, and you do the same thing to the 4. So the inequality sign is still the same, right? Minus a number won't change the inequality, and divided by a positive number won't change the inequality. So that's why we still have that. And now this is z. Okay, so P of z less than 4 minus mu over sigma. Okay, and we want CDF. Well, you know, for continuous random variable, the endpoint does not matter. So this is the same as z less than or equal to 4 minus mu over sigma. Right, so for the continuous random variable, okay, the endpoint doesn't matter because the probability at a single point is 0. The probability at a single point is 0. But this is only for continuous random variable. Okay? So that's why well, when you have like probability x between maybe a to b, this is the same as probability a less than or equal to a and less than or equal to b. Okay, and it's also the same as probability a less than or equal to x less than b is also equals to the probability of a less than x less than or equal to b. So in the last chapter, we know all of those 4 are different. But in this chapter, all of those 4 are the same. Yes, that's the special part of continuous random variable. Alright, so we continue. Less than equal is the CDF. So we have 4 minus mu over sigma. That equals, what do we start with? 0.02. Okay, so we are looking for the x value such that the CDF equals to 0.02. Let's go back to our table. Where is 0.02? So 0.02 is... which one is closest? I would say this is the closest. What is the corresponding x values? Negative 2.05. So negative 2.05. So we get 4 minus mu over sigma equals to negative 2.05. Okay. Alright. So, and sigma, we know sigma is 0.04. So 4 minus mu over 0.04 equals to negative 2.05. We multiply by 0.04 on both sides. And what do we get? We get minus 2.05 times 0.04. Put this in your calculator. You get negative 0.082. Well, now what is mu? Mu is then 4 when you move to the other side, it becomes positive 0.082. So that is 4.082. So that is the mean, okay? The mean is 4.082 ounce. Okay, so this is also in the direction like given the probability, how do you find the x values? And in fact, here we are looking for the mean. Okay, there could be other problems that the mean is given and asks you to find the standard deviation. Okay. Next, sometimes we can use the we can use the normal distribution to approximate discrete distribution. However, if we use normal distribution to approximate a discrete distribution, because we're using a continuous random variable to approximate a discrete random variable, we need continuity correction to improve the approximation. Okay, so let's look at example 4. X equals the number of power outage per month. Having mu is 11.6 and sigma is 3.3. If X can be approximated closely with a normal distribution, find the probability X greater or equal to 8 in any 1 month. Note, the number of outage is a discrete random variable. When using the normal distribution to approximate it, we should spread the value over a continuous scale. So, why is that? Let me draw some picture. Okay, so for continuous, so for discrete, so let's say this is a discrete random variable, then our values look like that. Okay, and let's say, just for example, maybe this is F5 and this is S6. This is like 4, 3, 2, 1, 7, 8, 9. Okay, so suppose this is our charts for the discrete random variable. Well, when you want to use a continuous random variable to approximate it, okay, now what happened? Well, the continuous random variable is something like this. Okay, so, well, what is the probability of, okay, let me call X be the discrete random variable. Okay, so what is the probability of X equals to 5? What's the probability of X equals to 5? Well, we know is this area. Okay, but if we want to use, let's say y is a continuous random variable, okay? We want to use y to approximate it. Well, you cannot just say, oh, that equals to p of y equals 5. That's not equal because we know for continuous random variable, the probability of a single point is 0. So if you use the probability y equals 5 to calculate, you only get 0. So that's not what we want, okay? So what do is we want to approximate it. So we want to still use this to calculate. So what is this guy? Well, this guy is probability of y is between, well, this is 4.5 and 5.5. So then the 5 is right at the middle. So 4.5 and 5.5. And then this is the interval from 4.5 to 5.5 of f of f of x dx, where f is the pdf of y. Okay, or you can use, if we use the CDF to calculate, you can use the CDF of 5.5. Okay, so this is a CDF. minus the CDF at 4.5 to calculate. Okay? Yeah, so this is the closest approximate because let me draw a picture. So you want to approximate the 5, right? The 5 there. Well, you can also choose to approximate using probability 5 to 6. Or you can use probability 4 to 5. But you can see it's not so close. So that's why if we can spread the value over a continuous scale, we used 4.5 and 5.5 to approximate it. It would be closer. Okay? So we don't use the green one. We use let me see. We use this guy. Okay, everybody? All right. So this is the probability at a single value. How about probability over a range? Okay, so over a range, let me see. So for example, if we are asking, okay, 2 less than x, less than equal to 6, something like that. Okay, so here x is the discrete random variable. Okay, so from 2 to 6, do you include the 2? Do you include the 2? So let me draw the picture here. So from 2 to 6, do you include the 2? No. Do you include 6? Yes. Okay, so if you want to use y, which is continuous random variable, to approximate it, how do you, what other values you want to pick? Okay, so you want to include the 6, so that's why you will have 6.5 here. You want to include the 3, but you don't want to include the 2. So that's why you use 2.5 here. So then this is the region we want to calculate. So that's the probability of 2.5 less than equal to y, less than equal or less than, doesn't matter for a continuous random variable, 6.5. So this is a continuous random variable. And then you can use PDF or CDF to calculate. All right. So this is the probability over a range. Okay. I strongly recommend you to draw the picture and then figure out, okay, what points you want to include. So you want to include that. So, here you want to include the 3. So you better pick 2.5. And on the right, you want to include the 6. You better pick 6.5. Okay. Do you want to practice one more? Okay, let's practice one more. Okay, so how about like 2 less than equal to x less than 6? Okay, if we want to draw a picture, we want to include the 2, but we don't want to include the 6, so we want to include the 5. Okay, so it equals to, you want to include the 2, so you do 1.5. You don't want to include the 6, you want to include the 5, so you do 5.5. So you're looking at those values. So that's probability 1.5 less than equal to y less than equal to 5.5. Okay, so we hope that we have enough exercise for this. So now let's go back to our example. So X is the number of power outage per month. We have the mu is 11.6, sigma is 3.3. And we're going to use a normal distribution to calculate. Find X is greater or equal to 8 in any one month. Okay, so X greater or equal to 8. Okay, so this back to example 4. X greater or equal to 8. So remember X is the discrete random variable. We want to use continuous random variable to approximate it. So greater or equal to 8 8 is here, greater equal, so like that. So you want to approximate it, then you want to include the 8, so you put 7.5. So that's probability y is greater or equal to 7.5. So now this is a continuous random variable. Okay? So next, well, greater or equal, that's not what we want because we want to have less than equal. So we want to use the CDF to calculate. Okay, so 1 minus P of y is less than 7.5. But remember, the endpoint doesn't matter. Less than is the same as less than equal for continuous random variable. Okay, but the y is a normal distribution. For normal distribution, we need to convert it to the standard normal distribution. So convert to the standard normal distribution. How do we do? 1 minus, we subtract, so z, we subtract the mean over the sigma. Okay, that's how we change to the standard normal distribution. What is mean? Mean what? 11.3 and 11.6 and 3.3. So y minus 11.6 over 3.3. Okay, y minus 11.6 over 3.3. And then we do the same thing to the 7.5. Great, because now that is our z, the standard normal distribution. And what is this number? So let's plot this in our calculator. I strongly recommend you to stop the video and try to solve the rest. And after you're done, we can check our answer together. So a lot of practice, very good for math class. Okay, so we plug in our calculator, we get negative 1.24. Do you have the same answer? Okay, so that is 1 minus, that is exactly phi of negative 1.24. All right, let's look at our table 3. So 1 minus phi of negative 1.24, negative 1, negative 1.24. Where is 4? Here. Okay, so negative 1.24 is this number, 0.1075. Okay, so 1 minus 0.1075. 1 minus 0.1075 is 0.8925. Right, everybody? So this is our probability of x greater or equal to 8. And that finished the problem. Don't forget, if you have questions, you can always print screen and ask me. Alright, bye!